This is Advanced Geometry with Mrs. RRubright. Today's lesson is 11.9, Explore Similar Solids. Alright, so given these rectangular prisms, tell whether the given rectangular prism is similar to the right rectangular prism shown at the right. So we're using this one, and we're seeing if these two are similar to this given prism. Alright, so we're looking at the base. 4 times 2 is 8. 2 times 2 is 4. 2 times 2 is so not 2. This would have to be 4. So this one is definitely not similar. If we did ratios, 8 over 4 is 2 over 1. 4 over 2 is 2 over 1. 2 over 2 is 1 over 1. They are not the same ratio, therefore they are not similar. 6 over 4 reduces to 3 over 2. 3 over 2. 3 over 2. We have a ratio of 3 over 2 on all three sides, therefore this one is similar. Alright, so this is just showing you those ratios and showing you that this one is not similar because of this little dude over here, that height is not the same proportion as the length and width. And on our second one, they are 2/3 all around. So yes, that one is similar with a ratio or scale factor of 2/3. Alright, so tell whether the pair of right solids is similar. Explain your reasoning. So if I did 12 over 9, right, the 12 over 9, that is going to reduce, 3 goes in here 4 times, 3 goes in here 3 times to 4/3. Let's look at the next side. So how about the 16 over 12? 16 over 12 is going to reduce, 4 goes in there 4 times, 4 goes in there 3 times to 4/3 as well. And let's look at the last side. Our last side, our height of 4 versus 3 is also that 4:3 ratio. Therefore, these are definitely similar triangles, or sorry, not triangles, wow, similar right rectangular prisms, and their scale factor would be 4:3. Their ratio is 4:3. All right, so looking at these two cones, tell whether the pair of right solids are similar. See if they're similar. Explain your reasoning. Okay, so this one has a height of 15 versus a height of 10. So 15 over 10 is going to reduce. 5 goes in there 3 times, 5 goes in there twice to a 3:2 ratio. And 10 over 5 is actually going to reduce to a 2:1 ratio because 5 goes in here twice, 5 goes in here once. 3 over 2 and 2 over 1 are not the same ratios, therefore these are not similar solids. These are not similar cones. Alright, so now, given that the cans are similar with a scale factor of 87 to 100, find the surface area and volume of the larger cans. This surface area and volume belong to the small can. Alright, so something that we can do. If you are given a scale factor and you are looking for a side length, right, you could always multiply by your scale factor once because a length or a height, that's one-dimensional. If you are looking for the surface area is two-dimensional. It's your unit squared. So you need to multiply by your scale factor twice. You have to square your scale factor, right? Multiply by your scale factor twice. If you are looking for volume, you need to multiply by your scale factor cubed, or multiply by your scale factor 3 times. So given the surface area of the smaller can of 51.84, we need to multiply by our scale factor to get the surface area of the larger can. Our scale factor, would we multiply by 87 over 100 or 100 over 87 to get a larger number? Get a larger number, 100 over 87. And because the surface area is squared. So at this point, you're supposed to pick up your calculator. All right, just found my calculator. So you need to put into your calculator 100 divided by 87 equals squared times 51.84 equals. And you should get 68.49. 68.49. And that's inches squared. And that is the surface area of number 2. All right, so now let's look for our volume. So So the volume of the smaller one is 28.27, and we need to multiply by our scale factor cubed. So just pick up your calculator. 100 divided by 87 equals cubed times 28.27 equals, and I got 42.93, and that is in inches cubed. 42.93 inches cubed. And once again, that is the volume for your second shape, your similar cylinder. And there you go. Those are your answers. All right, so the pyramids are similar. Pyramid P has a volume of 1,000 inches cubed. And volume Q, or the volume of Q, is 216 inches cubed. Find the scale factor of pyramid P to pyramid Q. All right, so let's think about this scale factor. So, what do we know? We know the volume of this one, we know the volume of this one. Well, just using what I already know in terms of math and not creating anything extra that you have to memorize, I know that if I took my volume of the first one and I multiplied it by my scale factor cubed, I would get the volume of the second one, correct? So if I just take this and I divide by 1,000, I would get that my surface area cubed is 216 over 1,000. Cube root. Cube root. I can cube them separately because the cube root of 1,000 is 10 and the cube root of 216 is 6. And 6/10 is 3/5. So 3/5. They want pyramid P to Q. They want P on top, then Q. P on top, larger number on top, larger number on top, smaller number on the bottom. And that is the ratio they are looking for. So how can I do this in my calculator if I don't want to actually do this math? I want to simplify this. So I could do 216 divided by 1,000 equals second 0, which is your cube root function, and that gives me 0.6. And say I just am really lazy today and I don't even want to work with turning this into a fraction. Second FD, which is that arrow on the very bottom if you have a non-solar calculator, and it literally puts it straight into 3/5 for me. It'll change it from the decimal into a fraction. So you could do this without even having to do much of the math by yourself at all, because your calculator pretty much does everything other than the initial setup. All right, so a store sells balls of yarn in 2 different sizes. The diameter of the larger ball is twice the diameter of the smaller ball. If the balls of yarn cost $7.50 and $1.50 respectively, which ball of yarn is the better buy? All right, so we have our ball of yarn, which is a cylinder. We have our ball of yarn. Okay. So one of them, we're going to create a radius. All right, so if the diameter of this one's twice the diameter of this one, what would the radius here be? Let's say that this one has a radius of 1 and this one has a radius of what? 2, twice that. All right, so the volume of this guy would be 4/3 pi r cubed. 1 cubed is just 1. 4/3 pi r cubed. 2 cubed is 8. They both have a 4/3, so just get rid of it. They both have a pi, so get rid of it. So we're really comparing 1 to 8, right? Our ratio is 1 to 8. So what would this cost? If this one says that it costs $1.50, so this would be $1.50 per 1 yard, per yard. And this guy costs $7.50 per 8 yards. So what would this one be per yard? Well, $7.50 divided by 8 tells me that this guy costs 94 cents per yard. So he is cheaper than this guy, right? This one is definitely cheaper. He's 94 cents a yard. This guy is $1.50 a yard. 8 yards of this first guy, if I wanted 8 yards of him to be the same amount, the same volume as this guy, 8 times $1.50 is 12. So he would cost $12. This big one would cost $12 if they were similar. But they're not. He only costs $7.50. So the better deal, by far, is our big ball. The larger one is definitely a better value. Actually, let's leave this up here for now. Okay. Oops. We're going to have to go right back into there. Somehow it stopped working on me. Sorry about that, guys. We're back and running. So the ratio of their cost was that 5 to 1. All right, and then they just are going through and showing us that, yes, the larger ball of yarn is the better buy, which we clearly discovered. All right, so on this next question, cube C has a surface area of 54 square units, and cube D has a surface area of 150 square units. Find the scale factor of C to D. Find the edge length of C and use the scale factor to find the volume of D. All right, so finding the edge length of C, why don't we just start right there? Because that is actually a pretty easy portion of this to do. So on C, we have an area of 54. It's the surface area of a cube. A cube has how many squares? How many squares make up a cube? 6. So take our 54 divided by 6, and we get that each square has an area of 9. What times what is 9? If each square has an area of 9, it must be a 3 by 3, right? So your cube is 3 by 3 by 3. 3 times 3 is 9, times 3 is, that would be your volume, sorry. So for surface area, you'd have 3 by 3 times 6 of that. So 9 times 6 is your 54, right? Side lengths of 3. So what is the edge length of C? 3. All right, what would be the edge length of D? You would do 150 divided by 6 is 25. 5 times 5 is 25. So that one has side lengths of 5. All right, so we have both of our cubes. This one has side lengths of 5. This has side lengths of 3. All right, so they want to know, what is the scale factor of C to D? C to D, 3 over 5. Find the edge length of C. The edge length is 3. What is the scale factor to find the volume of D? Well, your scale factor is 3/5. What is the volume of D? 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. The volume is 125 of D. Area of the base, 25 times the height of 5. And then our last problem. Calculate a new price for the larger ball of yarn so that neither ball would be a better price than the other. So once again, we're just going with that $1.25 for 1 yard, and we're seeing what 8 yards would be. So $1.25 times 8. It wasn't $1.25, was it? Was it $1.50? I don't remember. It was $1.50. $1.50, and we need 8 yards at $1.50 a yard. So $1.50 times 8 is going to give you $12, just like we found earlier. Remember, we did this part when we did $1.50 times 8, it would have cost $12. And instead, they got that ball of yarn for just $7.50, which was an amazing deal and a much better buy at their 90-something cents per yard. All right, well, that is everything for today's lesson. Today's lesson is 11.9, Explore Similar Solids. We hope you enjoyed the lesson. Please like and subscribe. Have a great day.